Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. Today we have a post by portswigger, some stuff about OAuth vulnerabilities and common OAuth flows, as well as some kernel bugs. So we'll start off with some of the web stuff, getting into portswigger's post on bypassing character block lists with Unicode overflows. So I'll let Z talk about this one.
Yeah, the issue just comes down to Unicode multi-byte characters. How many bytes are in a character? Who knows? Nobody knows how many bytes are in any. That's not exactly like it is a defined spec there. You can figure it out. It can be done, but parsing can be complicated. People make assumptions about what's being passed through. Maybe this is a wide character. It's not Unicode, it's just 2 bytes. Whatever. Assumptions get made in code all the time, or people try and just treat it as a sequence of bytes and just ignore the Unicode aspect. There's a lot of things that happen when it comes to character processing. You know, when we had ASCII, it was easy. Everything's just 1 byte. Sure, we were limited. We couldn't be inclusive of other, alphabets or anything else, but it was simple.
Hey, American English is all that matters, okay?
Yeah, I mean, Unicode has brought a lot of good things. Like, in fairness, there's been a lot of good, but processing it has always had bugs, and those bugs have been something I've been aware of kind of on the periphery. Like when I would get stuck on XSS or dealing with a filter, I'd always kind of play around with these things, dig into it, but it's not something I've ever spent like a really significant time researching. And so they're calling out this Unicode overflow attack, which has been around at least for a couple years here. They link off to a blog on InfoSec write-ups that's at least a few years old now, and obviously I think it was around before that too. And they also link off to another portswigger post explaining the email ad where they end up talking about this too. So it's not necessarily novel issue, but also was new to me, so I figured it's worth at least calling it out here, or at least first time I'm giving it any sort of real attention here. And that's just this Unicode code point truncation. They kind of call it out here. Happens when a server tries to store a Unicode character in a single byte. It'll just truncate it down. So that's kind of the easy case. Although they also have the example problem here from a string duff from character code, where if it is limited to 2 bytes, so rather than just being simple 1 byte thing, it's actually got 2 bytes. And if you give it any character that is more than 2 bytes, they have the example here where they're starting with 0 hex 10,000, which is one above the 2 byte limit. Then they add a little bit to it to actually set the value to something, and they get it to print off the string that comes from these rather large characters as just 1337. Very standard ASCII string because they overflowed, and so you're just getting that truncated down to just these last bits. Obviously, this is a very contrived example, but it just shows how, creating a string from character code and passing in some that might be attacker controlled could then be used to your advantage to bypass filters or whatever else. I believe in the bug bounty post they link off to, that ends up showing a use case where they were able to get a new line injection in headers and like set a cookie using that. I'm not sure if they actually, I'm going to open it up here to check. I'm not sure if they called this Unicode overflow or if they just kind of talk about this Unicode bug, but it's being linked here as like a reference. So I am making the assumption that that's kind of what's going on here as they talk about their final payload here is like, very much doesn't look like the correct characters, things getting truncated. Anyway, I thought it was a interesting technique, something to be aware of. They've added this into like the active scan and burp and such, so you'll be able to kind of try and scan for this sort of issue. It's just one of those things I think if you're dealing with a web application firewall, you're dealing with those character filters, you might be able to do something with this. It does kind of take some sort of bug happening in the processing of the inputs, but as I already kind of mentioned, when it comes to Unicode, there's a lot of complexity. And it's just one of those things that, in theory, Unicode isn't that difficult to parse, but in practice, there's just all these edge cases, all these random little things to kind of worry about with it, or that you can just deal with it, especially as you deal with multiple systems. being in play, multiple things just having disagreements, where in the splitting the email at post, they kind of talk about is, parser discrepancies in terms of how they're going to parse through it. And so you kind of have those sort of issues too. Yeah, I thought it was still cool. I wasn't aware of it, so shout out to it for that. But
Well, that's kind of the interesting thing is Unicode issues are something that everyone kind of knows is problematic. Like Unicode in general is problematic to deal with. It's not fun, but you don't necessarily think of how you can use that for an attack, which is where this post kind of directs your focus, I guess, is showing how you can use one specific form of it in the form of this truncation in order to do something potentially useful. They kind of link off to some examples. They don't go into examples other than the contrived one you had mentioned earlier. They kind of have one in like their header image, but not in the like contents of the blog post. But still, like you can kind of imagine where that could potentially pop up when you have like web app firewalls and stuff in play. So yeah, it's one of those things where it's kind of obvious in hindsight. And again, like everyone kind of knows Unicode sucks to deal with, but you might not think about it until it's called out to you. So
yeah, and I will just mention the header image here. The bug that's showcased in here is the one from the InfoSec write-ups post that they link to, where they get this sec cookie injected through the URL.
yeah, it does a good example illustrating it though at a quick glance. So I like how it could be useful. So yeah, cool post as always from portswigger. A little bit short compared to a lot of the posts we cover by them, but still has some useful information and stuff you can keep in mind. So continuing on web, we also have a post by Jose Catalan and Sismon Drazdal. I probably said those wrong. I'm sorry. But this is a post on common OAuth vulnerabilities. So they talk a little bit about like background on OAuth, some of the common flows you can have, and just generic vulnerabilities and problems that you can have with OAuth flows. See, I'll let you get into some of the details.
Yeah, so it is some generic issues, but also some things that you're maybe not thinking about. So yeah, it does start off as you said with the common flows: implicit flow, authorization code, and auth code with PKC. Um, that's probably background for a lot of you, and even some of the vulnerabilities that they do call out are probably somewhat familiar. They do have more flows than what I just mentioned, like resource owner password or all of that. Like they go through, I think, let me scroll through here. I think this is like client credentials. I just mentioned the resource owner one is actually one I don't see talked about very often. I think they've honestly got all of the flows that are in the spec in here, which would make sense since they're trying to overview OAuth. Anyway, yeah, when it comes to the attacks, some of these are going to be familiar, like the CServe attack, where basically get the token, CServe it, another application, or redirect attacks where you can either get the redirect URIs not being validated correctly, or, redirecting away after that, whatever it is, doing the redirect attack. And then there are a few here that I thought were interesting. They're not novel, of course, they're talking about actual vulnerabilities, but it's nice to see them laid out here and kind of given, I guess, like not necessarily even given a centralized name, because I'm sure things have been named before this, but the mutable claims attack is something we've talked about a handful of times. Like we've seen this a handful of times, and it just comes down to the case where in the OAuth specification, users are to be identified by the sub field, and that is the only thing that should be used to identify users, but there's no standard on what that identifier looks like. So maybe it's a UUID, maybe it's an email, maybe it's something else. And so a lot of systems will go and use the email field as an example, or some other field that's maybe specific to the system, but they'll use some other field, and there's the possibility that that other field won't actually be an immutable or like always identifying the same user. They use the example of login with Microsoft, where the sub field or subject field, or short for subject, is always this object ID. It is, immutable. It's something that can't be changed. But then if you use the email field, which is also sent, that is just attacker controlled and not even validated. And so if an application is logging in or logging a user in, they look at it, they see the email, and they're like, okay, here's the email for this account. Let's let them in. Not realizing that that email has been validated, they'll let them in. So we've seen that sort of attack before. Let's just break it down as part of like a general OAuth attack. Similarly, client confusion attack. I'm not sure if we've ever talked about this in the context of any sort of bug bounty issue or otherwise, to be honest. It's one because I feel like it's maybe come up once or twice, but I can't really think of where because it wouldn't have been like the main point. Main thing with this one is like if somebody creates a random website and they get people using it, when they get the access tokens back, in theory, they might be able to take that access token. So with the normal flow, with OAuth, or I say normal flow, when you're doing depending on the flow, they're using the implicit flow here, they're going to get the access token back, and then they could start like making calls using that access token. So they get the callback that contains the access token, then they're able to use that. Well, you can pass that along and pretend like that access token passed to another application and pretend like it's a callback, like you're being redirected. And that other application, if they don't validate properly checking the client ID that the access token was generated for, they might then let you log in as another user. It kind of requires that user log in on one website, and then you take that login and you're able to use it to log in on another website. As such, like I don't feel like we've ever really talked about this in bug bounty. I'm sure there have been bounties given out for that sort of issue because it is an issue on like the user side not doing that proper validation. I'm struggling to think of when we've actually covered this issue because it
Yeah,
is one of those things that it requires you to have a website that's going to be popular enough to get a lot of users or interesting users to attack on your website. Like it does require that sort of situation. So a slight bit of trust in a sense. Of course, people
it's
log
not
in
the
on
most
random
practical.
websites. Yeah, I mean, people will log in on random websites all the time. So like it's completely viable to do so. Um,
But if you can get them to do that, you probably have easier attack vectors in a lot of cases, which is why
not
maybe. Uh,
I mean, I wouldn't say so because this would be the case of like just uh I don't know your work has a login with your Microsoft account. So I have a random website. You can log in with your Microsoft account, and I copy that token and go pretend I'm now going to your work's website. Like there aren't a lot of equivalent
you would have
attacks.
to
I
have
mean,
some. You would have to have some target specific knowledge though to really like leverage that at all, right?
yeah, social engineering.
Yeah,
In that case, yeah. Otherwise, you just need like a popular website and assume people will have an account there and just try like credential, almost like credential stuffing. But I don't know.
yeah.
I just disagree on the other practical attacks because, like, I mean, you can attack their browser, but you probably don't have browser vulnerabilities to just waste on that. And like the other thing, I guess, no, I mean, so I was going to say like you'd create a website and just collect credentials that way, like not hash them or anything, not store them securely. But if you're using login with something, you're not even getting that. So no, like it feels like a pretty practical attack. It's just I guess the main thing is it's rather untargeted without social engineering. I don't know. I mean, it's a legitimate attack. It's absolutely something that should be tested for, and you should look for it. I'm sure there are bounties paid out on it. I just can't really think of any. And then one of the second to last one here is they talk about as a scope upgrade attack, and this just comes down to you have the scope value. That's how, like, when you log in with Discord or Google or whatever, usually says like they want access to your email, they want access to your geolocation information, whatever it is. Though that's specified by scope value that's sent along with the request to be approved. And while the specification, you're not supposed to send the scope, or you're supposed to send the scope during that initial like users logging in state, but not when you actually translate the authorization code back for an actual like usage code. And so if you send the scope value basically at the wrong time, there's a chance that it could overwrite or modify, and you can actually give yourself more scopes than you should have, because rather than looking back up what information was provided during the first request or was sent out during the first request, it might just trust what was just sent. And so it's another sort of situation like that. The last one here, redirect scheme hijacking, is something we have talked about also, and that's just basically working with application intents. And if you can get a redirect to happen to an intent, you might be able to either hijack the application, so become the application that handles that intent, or just get a redirect to an intent that an attacker does control. So it kind of just comes down to another redirect attack, just you're using intents instead. So yeah, honestly, I have over the last few weeks, Spectre will kind of maybe have realized this in our episode kind of preparation system. I've added a bunch of OAuth topics with like summaries of OAuth vulnerabilities. I swear it's probably been going on for like 3 months. I'd add a topic and then we drop it from the episode. Add a topic and I drop. This is the first time where I'm actually kind of covering one. Like I thought they did a better job here. It's not like the other posts were terrible. Yeah, but I felt like they did a good job here and kind of laid out. Well, none of these were things I was unfamiliar with, like the idea of the, especially the mutable subject thing. What do they call it here? Mutable claims. Obviously, I'm aware of that. We've talked about it's a cool attack in general, I think. But I also just never really applied that. I'd always think about that, especially claims. I'd always think about that on the side of like JWTs and not so much inside of OAuth. But like it applies to OAuth. We've seen it in OAuth. So it's not like completely unknown, but I don't know. They brought things together here, I thought, pretty well. And of course, including all these different floats, including several of the fairly uncommon ones, is also a nice add to have in here.
Yeah, and I also appreciate their diagrams because, when you're getting into some of these more complicated flows, especially, like I'm sure even some of you listening when Z was trying to talk about it, like might have found it a little bit tricky to follow because you can have like so many steps and multiple parties that are involved, and trying to keep track of it all in your head or something is just at least for me, it's not an easy thing to do. So the diagrams here, are very like readable, straightforward. I've seen some OAuth diagrams that are just a nightmare to try to read, and I'm looking at it and it feels like I'm trying to like solve an equation or something. Like it puts me off. But these diagrams are very useful, I think. So
yeah, the diagrams are nice. I mean, I'm sorry if I didn't, necessarily explain some of that well enough. Like some of the diagrams are easy.
To be clear, I wasn't trying to rip on you. I think you were explaining well. It's just it can be hard for people to understand just from audio only. It's just such a complex thing to keep in mind.
I get what you were saying. It's good, or like it's all good. I was just going to say, like, I mean, some of these things have like when I was just talking about the scope upgrade attack, like the steps on this are like there's 18 steps in this graph, I think, or 17. 18. Yeah. 18 steps in the graph. Like there's a lot going on. There's a lot of steps that you kind of need to follow through.
Yeah. But yeah, this post does a good job of laying it out and everything. So yeah, I think it's worthy of checking it out if you're a little bit fuzzy or want to refresher on some OAuth vulnerabilities and things to look for. So getting into some of our operating system level issues, we have a post by Star Labs on the Windows Telephony service and a vulnerability in there. It is not a kernel bug, but rather in the telephony service userland process, and it's a use after free, but there's some interesting parts to it when it comes to the actual exploitation of it. I'll let Z get into it.
Yeah, although I'll just mention the vulnerability itself, we're not going to dive into that. If you kind of want more of the details, they do have a bit here. It's ultimately use after free from a dangling pointer. I think we just talked about a similar type of bug last episode. It's not uncommon. But anyway, when it comes to the exploitation, I'm also going to skip a lot of things on the exploitation, like creating the overlapping object and kind of their object choices there. But what they did have
that part was a little bit interesting. Sorry.
Oh, no, go into it if you want to.
Okay, so
I really want to talk about the control flow guard bypass.
For sure, that is definitely the cherry on top of the post. But yeah, so the UAF was in this free dialog instance function. It's not super interesting, like C said. It'll basically just search for this gold object by its magic bytes, and it'll free it regardless of whether or not the context handle object owns it. Which seems like a kind of dumb use after free. And then this TUI spy DLL callback function will access a function table inside of that gold object, and that object that can be left dangling has a function pointer that can be invoked. So yeah, it's a little bit weird where it's a user space process and not the kernel. A lot of the time when we talk about UAFs, especially recently, they've been kernel. The advantage of that being the kernel has tons of different objects and primitives. A lot of the time you have techniques that are years old, especially in Windows, that you can just like reuse. There's a lot of generic techniques. Not so much when it comes to the user space process. I thought it was a little bit cool how they got their overlap, because what they used was basically this T request make call function. It would open a registry key that was accessible to everybody, like untrusted users could modify this key, and it would allocate a buffer to store the key values. So they crafted their fake object through the registry, which I thought was a little bit cool. So yeah, I did want to call that out quickly, but other than that, it is a fairly straightforward use after free. But the other challenge is the control flow guard, which I'll let Z talk about.
Yeah, I mean, I more like this post because it just shows how, like, yeah, control flow guard can be there. It means you're not going to be pulling off a ROP chain or like something really easy sort of situations, like the really generic attacks that we've
Your
seen for years.
go-tos.
Yeah,
Yeah.
but it's also like they deal with it in a fairly easy way here. The exploit they end up going here with, obviously, so with the use after free, they're able to execute functions. It's just there's control flow guard protecting what they can actually call into, such they can't just like call into the middle of a function, or so they can't just use like a random ROP gadget to start a chain or whatever. But they
You have
can
to have
still
a valid call
call,
target. Yeah.
yeah, call valid call targets, valid functions. So they have very powerful functions that they can just call, like virtual alloc, which they call in order to create a read, write, and executable region. Now that sounds great because it's like, read, write, execute. They can just write their own code in there. Can't quite just write their own code. I mean, they kind of could. It is executable, but it's not a valid call target. So still limited on that front. So they create this RWX region, and in that region, they write the path to a custom DLL, which is this case, their path to our hack.dll. Whatever it is, they write a path out into this memory region, then they're able to just call another function that already exists, and they'd be allowed to call because it exists. Load library. Load library loads a DLL. The DLL includes, a Unicode or whatever, so it runs on startup, like once it's loaded. And at that point, they have code executing in the program bypassing CFG. Does require having that hack DLL there that can be loaded in. Which actually, do they talk about? I guess it's an EOP, so they can have it. Never mind. They don't really need to do anything special for that. This isn't a remote attack. But yeah, just calling basically virtual alloc plus a load library call. They bypassed control flow guard and still got their code execution with it. And that's the thing. Like, it's a very simple attack method to just bypass this. In fact, I would even say that this is easier to understand than return-oriented programming, and yet more powerful in this case. Of course, it has the higher requirement. You're getting it from a DLL. You're getting the code to run from a DLL, so you have to replace that, but fairly easy to kind of comprehend this bypass.
Yeah, I mean, it's basically like when you typically learn ROP, you typically learn ret to libc first, and this is kind of that same idea of just reusing functions instead of individual gadgets and chaining that way. One thing I'm not super clear on in the post, and maybe this is just me missing something obvious, but they don't mention like ASLR at all, do they? Because they mentioned leaking the lower 32 bits of, so they call malloc to get a pointer, and they leak the lowest 32 bits in order to get a valid pointer for their DLL path. But they don't talk about how they actually are able to resolve malloc's address in the first place. I don't know if it's just the binary isn't using ASLR, or because that would be kind of surprising if a Windows service wasn't using ASLR.
Well, I mean, at the very, yeah. Sorry, my mind was immediately going to Pi versus ASLR, and I was going to say, well, maybe they're not Pi, but still should have ASLR.
Yeah,
I and Pi, I know it's a Linux term, but you know what I mean.
Yeah.
Uh,
Yeah, I don't feel like playing into the game of Microsoft redefining every term in existence either.
but to your question there, yeah, I recall them leaking. So as I was reading through this, yeah, I saw they leaked the lower 32-bit. Um, they do seem to. No, never mind. I thought I noticed something in one of the screenshots here. Yeah, I don't have an answer for you. I'll just put it that
Yeah.
way. Um,
It's just my mind kind of went there because when you have these bugs where you can immediately get control of the instruction pointer, like you have a function pointer hijack right off rip, it's one of those things where it sounds amazing. You're like, wow, I get code exec immediately. I don't even really have to work hard for it. But the trade-off there, the drawback is you have to put a valid pointer there that it can execute or you're going to crash. So a
yeah,
lot of
and
the
they
time you
do.
will need some kind of info leak first, but they get their info leak for the data at least from their code execution. So it's a little bit weird.
Yeah, I saw the call to malloc. I assumed that was just part of the normal flow, but no, as you said, it's part of the use after free. They invoke the call to malloc. Um,
Yeah.
yeah, I'm not. I mean, they don't talk about ASLR as you said. You maybe want to look at the use after free here. Maybe they're able to get like partial override or like dangling because something's dangling or something in there. Like they don't need to do the whole
Yeah,
thing.
there
But
might be
yeah,
something that I'm missing that's kind of obvious, and in which case anyone who's listening, if you're aware of it, then please leave it as a comment because I'm personally kind of curious on it. But
yeah,
yeah,
because the
because I was
objects being used might tell a lot about what information. Because it's possible that the objects being overlaid has
yeah.
some of those like has a pointer that's already aligned properly, so they only need lower 32 or something.
Yeah, like if the registry key value that they use to get control over the object, maybe if that can get updated again, with like the dangling contents, maybe that's how they can get their leak of a pointer or something. But yeah, from what I can see, they don't really talk about it, so it's just kind of left as a question mark. Either
Yeah,
way,
and
that
I
they don't have to deal with it for their main exploit.
yeah, and I will call out one thing. Like I added this post as I want to talk about the control flow bypass. It wasn't going to focus too much on the rest of it. But I will just mention, since we are talking about 32-bit leak, something that they have a picture of, kind of them leaking stuff. But I guess we don't have like, if could he do an offset read, lower 32 bits of like basically minus one index back. So your lower 32 bits is actually the upper third, like a non-aligned read. Basically, is what I'm
Oh,
thinking. So
yeah,
it's always the
maybe.
lower 32. And, the only thing that kind of makes me start thinking along those lines, because I do see this leak low 32-bit address 0x80, which, just seeing the 80 at the start kind of makes me think towards like a code section. But like, yeah, I don't think they called that out. It might be something that is obvious once you if you actually sit down with the objects and take a look.
But yeah, that's sort of an aside. The cool part, like you said, is, you know, them getting around the CFG. Now, CFG being this coarse grained is something that has been kind of well documented and talked about. I think we've talked about it before as well.
Yeah.
You can have more fine grained CFI where you have function pointers that are supposed to go to a specific call target and that's checked against the specific call target. But with Windows CFG, it's pretty broad. You can just kind of invoke whatever as long as it's a valid function, which opens up a lot of your attack possibility. But still, it's fun seeing some of the ways you can get around a CFG, and using load library to do the DLL hijack like that is a neat strategy. Maybe it's common in the Windows space. Both Z and I don't really operate much in the Windows space, at least like modern Windows. So yeah, it's fun to see some of the techniques that come out of that. Now, it's worth noting there is like a second half to this post where they also talk about another vulnerability. Again, though, like I'm not going to talk about it too much. It's not super interesting. It basically just comes down to the fact that this function on a registry value will invoke this WC super function to convert it to uppercase, but it doesn't actually, like, that function doesn't validate if the input string is null terminated. So you could just pass a registry key that's like not null terminated, and it'll just read beyond the buffer, which could be used for info leak. Now they don't. So it could be possible that that info leak is how they got around ASLR. I don't believe they call that out specifically, but that might be the missing puzzle piece there. I'm not totally sure. But yeah, I mean, kind of a fun Windows chain, and it's a little bit interesting to see something in the userland RPC service like this, because a lot of the Windows issues we've covered in the recent past have been in the kernel. So bit of a shake up there.
Yeah, it is. It's a little bit different. Although I've actually been seeing a bunch of posts in Windows Telephony service
Seems to be a bit
lately.
of a bug farm. Yeah, I've seen a couple too.
Yeah, I've been seeing a bunch of them. We haven't been covering them, but I have seen quite a few.
I believe, let me just double check this, but I believe Project Zero might have just put out a post about it too. Oh, okay, no, that was a different Windows thing. Never mind. Sorry. But yeah, no, there's some of these Windows services seem to be a bit of a farm, and we'll probably see them again.
Yeah, and I mean, it's one of those cases of just like the shifting meta as the core becomes more and more secured. These services, and we've been talking about that a little bit in terms of the Android impact, where pivoting through services to get higher privileges. On Windows, a little bit different since a lot of these services will just be running with super high privileges. I think it's just kind of representative of that shift. Maybe the kernel is becoming more difficult to get the exploits in. So start looking at. I mean, it's not like it's not like people haven't looked at the services before, but it is that shifting meta also.
Yeah, you can see there's a bit of a shift in focus on that for sure. So yeah, getting into our last topic, which is a kernel bug. There's this really cool post that was posted by JPRX on a vulnerability in the macOS kernel. It's a named vulnerability. It's been a little while since we've had one of those. They called it TRAVERTINE, but it is effectively a data race. And what makes it really fun is it's in an area of the code that should be safe from race conditions. So they talk a little bit about SMR regions here, or safe memory reclamation. It's pretty similar to read copy update, if you're familiar with that from Linux. The whole idea is you can have these SMR regions. You can have as many readers as you want that can enter an SMR section, and then writers will lock to serialize their writes to update a pointer, and that should be atomic, and then they'll unlock. And the premise there is that as long as the write update of the pointer is atomic, readers will always have some valid pointer to read from. It might be older data, it might not be the most up-to-date copy of the information, but it's not going to point to invalid memory or like a dangling pointer or something like that.
Okay, so I want to interrupt you because I thought safe memory reclamation was lock free. And in fact, they say lock free context, and then you're talking about locking and saying that the writers will lock. So my understanding was that you're expected to use an atomic write. And I believe that's also where the bug is, so I don't want to jump too far ahead, but like I don't believe they're explicitly doing any locking here. The whole principle is that basically the data is protected by that single pointer that then points to the proper data. You have like the pointer points to the data, and then all your readers, when they want to read that data, they read the pointer, they read where it points. But when somebody wants to update it, they just need to atomically make that right of just updating that single pointer after they have created a new piece of data with everything updated, rather than updating the old object.
So to explain it, they state here on the writer side, a lock is used to serialize the writers, ensuring there can only be one writer at a time, and writers use atomic updates to publish new versions. So the readers are lockless, but to write, you still need to serialize to make sure there's only one entity writing
Okay,
the pointer.
My bad then.
Yeah, no worries. So yeah, as long as that write is atomic, it should be fine having as many readers entering without locking as needed. But the problem kind of comes into play is if that right isn't atomic. Because what you can end up having is partial updates or partial reads where you can have two valid pointers that, if you have the right data race and the right timing that hits, you have part of one pointer and part of another one, kind of making this malformed pointer. And in this case, the chaos cred proc update function, which is used for like their credential system, failed to set the cred pointer of the process atomically. It used the wrong function because ultimately the function it used memcopy, which would copy the bytes for the whole structure, including the pointer, using the rep move sb instruction, which is not an atomic operation. And it's sort of funny because this sort of scenario, this bug, is not something you have to worry about a lot of the time in x86. In x86, for the most part, like if you're moving a register to memory or whatever, those are supposed to be atomic. You kind of have strong memory ordering guarantees in x86. It's only when you use like rep move sb and these instructions where you don't have that atomic guarantee anymore. So yeah, I mean, because of that, you could have a malformed pointer that could potentially point to something garbage and cause a crash, or in theory, it could point to another credential that the process shouldn't have ownership over, that it shouldn't point to. So it could be used for a privilege escalation. Now, because this is a data race and the race is so tight, like you're not even racing between two instructions, you're basically trying to race like the update of the same pointer between two threads. That is an incredibly small window. So they stayed outright, like this race is really hard to actually win, because a lot of the times, like even if you get it to happen and you get like that partial update, that pointer could very well just point to something innocuous and not cause any useful side effects. It might not crash. It might not point to a more privileged credential. It might just, point to some other credentials that's similar or even the same. So yeah, like in practice, actually exploiting this bug would be very difficult. They were able to demonstrate a crash due to improper alignment. So they were able to cause that, but they said that in theory it could be used for privesc, but actually causing that to happen would be really hard. But still, I think the bug is very cool here. It's not too often you get to see like the consequences of things not being atomic, especially in x86. Like I said, it's not something you have to worry about a lot of the time. Now, they do state that this could potentially be a problem in ARM as well, but they weren't able to trigger the crash. They believe that might just be due to how memcopy is optimized in the ARM implementation, where it's optimized to copy larger blocks of bytes at a time. So it might still be vulnerable. It's just even harder to hit because those bytes are being copied over so quickly by comparison. But yeah, awesome bug. Pretty easily understandable, even if you're not familiar with like a lot of the concurrency mechanisms and like read copy update or SMR. It explains it very well towards the top end of this post. So yeah, I love this post.
Yeah, although I will just mention with regards to my confusion on the locking there, I guess what kind of had me confused is the fact that we're talking about both doing. So oftentimes when I think about something being done atomically, I really just think about like, so atomic generally means it's being done as like one group, one atom. It can't be broken up. And so you can kind of create that using locks, but then this is all lock are supposed to be lock free. But in this case, like there are kind of two different considerations going on where they have the locking so you don't have multiple writers. Plus you also have just, it needs to be done. The write itself needs to be done atomically because you will have multiple readers.
Yeah, exactly.
So it was that distinction that I was a bit confused on.
Yeah, and that's the thing with like where concurrency gets so hard is you have so many like different contexts in a lot of cases that you have to keep in mind, and it can definitely make it tricky to follow. And it's something as simple as using the wrong macro can cause a ton of problems if the stars align, so to speak. So yeah, it is a race, but it's not your conventional one. It's pretty cool and unique. I haven't really seen this like a data race being talked about and exploited in this manner exactly.
Yeah, I mean, most data races are pretty benign. Like they don't really have. So if you're unfamiliar, like you've got race conditions, which are generally what we talk about when it comes to security, and then you've got data races, which is entirely different bug class that can also involve a race condition. Like you can have issues with that, but they are separate bugs, separate things.
Yeah.
So yeah, that's also kind of some confusing terminology, but different origins. But yeah, I thought it's still a cool bug, like I said, because you don't really see this sort of data race having much of an impact often. And sure, it's difficult to hit, but it's a cool find. It's a cool bug.
Yeah, 100%. So, yeah, I believe that's all the topics we have for today. So, unless you have any last minute thoughts, see, we'll wrap it up there.
Yes, we could quickly mention, as we have before, but we do have the training coming up. I don't have a link ready for that.
Yep, we are going to be giving a training on hypervisor security and virtualization. So that's going to be at Hardware.io in May. So if you know someone who would be interested in that, or would be interested in it yourself, feel free to recommend that or check it out. We would love to have some signups because Z and I would like to continue doing some of these trainings. So yeah, we'd really appreciate any shout out you'd be willing to give us. But yeah, so as always, thanks goes out to everyone who tuned in, and we will see you in the next episode.